this is Ladyada.
Hey everybody, I am at my desk today, hacking, coding, staying cool. So let's see what we're up to. We'll also do a great search. Any news from the world of hacking and making?
Well, we might be publishing a bunch of stuff in various places this week. And I'm probably going to tell some people that are dunking on open source people to stop it. So you can watch what that is going to turn into. My intention is to have the open source printing figurehead, Joseph Prusa, stop saying open source is the reason for all of the reasons 3D printing is not working out. So I just have to say, like, stop it. And if you're going to say it's patents, where are the patents? If you're going to say it's open source, where are the other open source designs? That's what I'm doing this week.
Okay.
So everybody, let me just tell you something. You might want to do open source, you might not want, but let me tell you, it has nothing to do with a 3D printing company succeeding or failing. It really doesn't. And so it sucks when people decide to do a speaking tour and say, open source is the reason that everything is terrible. So I think open source is great because I see all the great stuff you make with it and all the things that customers make with it and all the things that the community makes with it and all the things that they make, share, and remix. So speaking of,
let's get to it. Okay, so let's go to the computer. I have my list of what we're gonna chat about.
you got a list?
I do. I need to do that list. So the first thing is I realized this week that Claude Code now is supported natively on Windows, which is great. It was, worked natively on Mac through Terminal and through Linux, also Terminal, because they have, they have terminal support. For Windows, until now, I was using WSL2 with Debian. And I actually really liked it. Like, there's nothing wrong with Debian WSL2. I really liked, you get Debian, you get all the tools. It's kind of nice. You can, it has grep and find it or whatever. The issue is that when I was compiling, the way I like to work is I have the code that I'm working on live in Dropbox, which you can see here. And the reason I do that is sometimes I'm watching a baby and then there's nap time and then I have to go upstairs. And so sometimes I'm at my desk computer and sometimes I'm at my laptop. And sometimes I have another laptop that, I have attached to my bed so that if I feel sick or whatever, I can type in bed. There's having all these old Dell laptops kicking around. I don't need them to be particularly fast because, I'm not doing intense computation. But having Dropbox means all my code is always synced. Yes, is it slower? Sure. But I use that and then I use GitHub for when I actually commit the code. So that's my work style. The problem is that Dropbox is already kind of slow. It slows down your file system. And then WSL2 slowed it down even more. So compiling was actually taking minutes. And there's no reason for it to take this long to compile simple Arduino code. And it's not even more complicated code that I'm working on. This is actually kind of simple stuff. So having it run natively in PowerShell, there's downsides. I really miss a lot of the command line tools. So I'm installing them, just stuff like wget and curl and find. They're not built into PowerShell. You can add them. They're available. And of course, you can also, I think, run this through MSys maybe. But, it's worth it to get the speed up. So, I just have to upload my code a little bit. But, what's nice is that I can do... I can write code and do, I like to do the compilation, upload, test stuff through, so let me see, I can do, I do Plunk format, compile. So I can do, the serial capture and I have the Claude Code LLM read the output from the serial port and it checks am I writing to the right registers? Are the values correct? Am I getting, these Lux calculations? I'm working on this sensor. So far, so good. So basically, if you happen to be using Claude Code in Windows, I do suggest, I still have it running in WSL2, but now I also have it running on Windows Native and I'm liking it. And definitely it's sped me up a little bit. So I took that, having gotten it working a couple days ago, I kind of just reworked all of my tools. I don't have minicom, so I had to write a little Python script to do serial output with timeouts because LLMs don't understand timeouts and stuff. So I worked on a couple of sensors. So one is the VEML6046, which I think I designed this and I showed it off on a previous desk of Ladyada. It's just, I wanted another like RGB sensor. This one also does lux. It's like a nice little sensor. You know, DigiKey has it in stock. And, you know, I like the VEML series. Vishay is just really good at this stuff. So, you know, this sensor is about $2. It's good. You know, one thing about optical sensors is either they last forever or they get discontinued. So, example, like the OPT, you know, of course, it's probably going to be in stock the moment I look. But we did the OPT 4048, and it's a really cool XYZ sensor, and it's out of stock again. And it's kind of like always out of stock. It's also quite popular. And it's like, you know, maybe it'll be in stock in 2 weeks, but I just find that like a little odd. I don't know, something about optical sensors. Anyways, so we got that going. And what's really cool is, you know, I'm actually getting a lot of libraries done in Arduino because Claude Code is letting me do like all of the annoying work, which is parsing the data sheet and then doing the setters and getters and adding it. I still do the hand test to make sure the code is correct. And of course I review it and I look at the registers, but there's just so much typing I don't have to do. And I get to like really make the library fully fledged. So what I like now is it actually even, I told Claude, like when you do a commit, like at yourself, so people can see that it was committed with Claude Code. And then I'm trying to think, I think I also, yeah, I add it to the header file. So people know. I don't have the ability yet to, I would love to be able to like capture the session and attach it, but I often have, again, multiple sessions. I don't have a way of doing that yet, but if I can do that, I like doing that with ChatGPT. If I can do that again, I'll do that. So that's happening. So you're gonna see a lot more libraries coming out. The BQ, last week we talked about the BQ25.E. They're all, it's like 2525. There's two I'm working on. The 25628 was the buck converter with I2C, and I actually like totally didn't understand how it worked. So thankfully, I did spend time on the library, but it was only like 3 hours, because at the end, what I realized is I limit is not the same as the charge current rate. I limit is really like the hard limit on total current input. And so I thought that you could like set the default charge current in hardware and then like tweak it in I2C if necessary. But turns out, no, the default I2C charge rate is like 40 milliamps. And if you want it to be higher, you have to connect over I2C, which I don't like. I would have really liked it if it was like you could set the defaults, and then if you had a microcontroller, you could do something more advanced. I did add this library to the library manager. I might use this chip eventually, but I don't know if I'm going to have a breakout because I don't know how useful it would be. I think it would be confusing to people because they would be like, what do you mean I have to connect over I2C to charge the chip at more than like 40 milliamps? Not very interesting. So I think what I'm going to do instead is I'm going to get some of, I'm doing all these little breakouts, just practicing with them with this new Claude Code setup I have, and then I'm going to get back to the 25798, which I did get like halfway through, but this was just like such a beast that I kind of got exhausted. But I do want to get back to solar. But what I did instead that I finished this week, so we can now go to the overhead and talk about some cool hardware. One, I got the BMP, the 580 and the 581 were great. I think I talked about that last week, and I got that driver done. And then this week, I got the prototype for the 585, which is like the ported version. And true to the Bosch library, it did basically just work. So what's cool is I get 3 sensors with only 1 library. And I've submitted the library to the manager, and it works super good. So we have like now the latest Bosch sensor. And then I got, I'll unplug this 1 second. Let me just shut this down. I got the e-ink bonnet protos in. And so I think we designed this on a previous desk of Ladyada. So you got that standard 24-pin e-ink connector. So it's like you can connect, anything from this teeny, well, this is not even that teeny, but I've got like, hold on, I've got like a really teeny one on the floor here. This like super small 1.5 inch up to this chonky 7.5 inch and beyond, monochrome or tricolor or even quad color ink displays. There's also the ASAP like 7 color displays, which maybe I'll get some of those. And I made a board, you can select which resistor value you need, because some want 0.5, some want 3 for there's a little boost converter feedback transistor. And I added a couple of fun things, like if you wanted to connect NeoPixels or something, I added a digital output with power here. There's 2 buttons, so you can kind of select different modes, power, breakouts for all the GPIOs above, and a speaker output. Well, stem QT, of course, because I2C for sensing. And then speaker, because I was actually thinking, like, if you're going to have e-ink display, it would be cool to have it do like audio notifications as well, to tell you, like, ding dong, like I've updated the e-ink, it's refreshing.
Price has changed.
What price has changed? Or, you know, maybe you have, we were playing with that Kitten TTS, which is, we have a guide up on it, thanks to Tim, which is a local AI model that can do really good text-to-speech, in my opinion, better than Festival, which is ironic because it's like that was a project that hundreds of PhDs, I think, spent time on. And they did a really good job, but it's like this text-to-speech does really well. It could be cool to have e-ink, and then maybe for accessibility, it also does text-to-speech. Anyway, so this is it on the Raspberry Pi, and I got it tested on the Raspberry Pi, and I even got the I2S amplifier working. It works cool, so you can use your speaker. And then we are still working on, we were playing with this particle tachyon. So this board, what I kind of like is that it's battery powered, so I can unplug it, and it has cellular as well. And it does have pinout compatibility with the Raspberry Pi. So they did, the tech team there did add some support to Blinka, and then we got that merged into mainline. So actually, let's go to the computer and I'll show so people can play with it. So if you go to Blinka, whoops. Look at closed. So yeah, we did Tachyon support here. So this is the PR for it, and it has SPI. So the SPI works because I got that working. That's how we do the EPD display. I2C does work, although I think the onboard stemma QT needs a tweak, but I figured we would do that like once we got stuff working. And the basic GPIO also works because that's also needed for the EPD. So it's kind of cool because, one of the nice things about Blinka and CircuitPython is the whole goal of the way we structured the API was the libraries that we write for sensors, for e-ink displays, for whatever, the OLEDs all work whether it's a microcontroller or microcomputer, because I2C and SPI are like in GPIO are essentially the same. Some might be faster, some might get to use NumPy, some might be better at NeoPixel because it has native NeoPixel support like that. I don't believe the Qualcomm chip. They don't think they added any bitbang support. But so we've got particle tachyon, and this is going to be. I don't think we've done a release yet. We do a release every. Oh no, we did. So we did a release yesterday, which is great. So some fixes and tachyon support. So if folks want to get Blinka support, they could just do a pip install now. They don't have to go through the git clone of the fork, which is good because as we do bug fixes and stuff, it'll get wrapped up. So that's cool. And then, so on the e-ink, let me go here. So we have it doing this cool Escher. So you go to the overhead, I'll just show it refreshing. And this is just a cool Escher image. And what's nice is, of course, you've got Linux and cellular, so you could send images from anywhere in the world and have it refresh. And then with the battery and solar power, you could have it, run completely independently. So it's kind of a neat platform. Something that's really hard to do with a classic Raspberry Pi, but we're getting closer and closer. So this board also got tested fully, and we're going to send that one out as well.
It looks great.
Yeah, it looks good. And this is the 7.5 inch that we put in the store, and we'll put, like I said, we have tricolor and 7-color ones.
Can you see through the back of it?
Yeah, it's a little. Cool. It's got the. It doesn't have a backlight, right?
Oh,
so it's
cool.
It's reflective. Sometimes you can put a front light on top of it. People do that. Okay, so how are we doing on time? I think that's all I got for the desk.
We're at 15 minutes.
Perfect. Let's go to the Great Search.
It's time.
It's time.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada uses her power of engineering to help you. Yes, you find things on digikey.com. Ladyada, what are you looking for this week?
Okay, this week we actually had a request, and I thought this would be, and I was like, this is a really good request, and also I will put it on the Great Search, and I gave them some advice. So we have in the shop we have these PT1000, PT100 RTD sensors. These are ultra stable, precise temperature sensors that can measure like a remote sensing, and they have like a wide temperature range. They're a little expensive because they use true platinum, but like they're extremely stable and reliable. So these are used for like people when they really need like good temperature readings that are consistent, have a wide range. You can do 3 or 4 wires, so you have the resistance of the wires taken into account. It's all really good stuff. And we tend to use the Max 31865, which is an SPI sensor that does a lot of the work for you. And look, I do recommend this sensor. It's in stock at DigiKey, originally Maxim, now Analog Devices. It's a great RTD amplifier that does all the work for you. Like it's like once you follow the data sheet, you will get the actual temperature out. And you just have to have the matching, you tell what the matching resistor is, what the resistance of the platinum piece. The person was asking, well, this is SPI and I really want I2C. And what's interesting is that there is for thermocouples, there is the MCP 96001 series, and these are I2C. They're not inexpensive, but they are I2C thermocouple readers, so they can do, I think, like K and J type thermocouples. Thermocouples are not as precise or accurate as RTDs, and so this person said, look, I want to do RTD stuff, but I want it to be over I2C. And I quickly looked and there is no I2C like specific RTD sensor. But the good news about RTDs is they're very linear because they are like this piece of platinum, and as it heats and cools, the resistance like changes a little bit because it's a very thin piece of platinum. You just need if you have 0.1 resistor dividers or the Wheatstone bridge, you can use an analog digital converter. And so I thought we would look for today on the Great Search is a 24-bit I2C analog digital converter chip. And then you would be able to use some resistors and basically do the RTD reading. And you'd have to do the math, but the math isn't too bad, to be honest. So let's look for ADCs. And there's a lot. There's 14,000 ADCs, not surprising. So let's look at only active ones. And so that gets rid of all the ones that have been discontinued. And number of bits, as I mentioned, we really want a 24 or greater bits because to get the real, if you look at like any of the RTD sensors, they really use 24-bit ADCs. Now, the good news is it doesn't have to be very fast, but it is, you do need 24 bits, and you want it to be pretty good quality. Okay, next step, we should filter it out so it's only I2C. So let's search for data interface and search for I2C and select that. Okay, now I only have like 25 options. And then let's get rid of marketplace just because it doesn't even matter. And then we'll look at also normally stocked because some of these are like, not really stocked or made anymore, like they're rare. Okay, so then let's sort by price real fast, just because we care. Oh, sorry, and surface mount. I think there's like one that's through hole. I don't know how they got a 24-bit ADC in through hole, but I don't know. Somebody wants it. So starting off, so some of these are duplicates because they're just these are different package types like tube versus tape and reel or cut tape. That's okay. So there's the NAU 7802. And we have a breakout for this chip. We use it for strain gauges. And it is a 24-bit ADC, and it's really kind of designed for strain gauges. I wouldn't call it a super, it does have precision, but I wouldn't call it accurate. It's a very the price reflects like what you're going to get. It does work, but I would use it for stuff like strain gauges where you calibrate it and it's okay if there's a little bit of drift. Whereas for RTDs, I think we should get maybe a higher grade of sensor. So there's the LTC 2485 and Linear Tech analog devices. You know, you're going to get an amazing ADC. This one does do differential, which we probably want, because if we're doing this Wheatstone bridge, having differential measurements is you're going to get better results, or not more accurate, but you're not going to deal with common mode as much. You'll, as long as you stay in the middle there, you can get pretty good accuracy and precision. But the sampling rate's quite low. It's only 7.5 samples per second, which is not unreasonable. And also there's only one input, which I think is okay. And it costs about like $4 in quantity. And then there's the 2493. This one is twice as fast. So you're going to get 4 single-ended or 2 differential inputs at 15. And this is like 75 cents more. So this is kind of like the slightly fancier version of the 2485. And then we've also got the ADS 1219. And the 1219 beefs it up to like 1K sample. So this is, this is a little bit more expensive. This is $1 more than the 2485. Maybe I can get this over here. This is not so important. I don't really care about package either. Boop. And then series, I don't care about that. And they're all going to be active somewhere. Maybe eventually they can have a little hidey. Okay. So 24-bit, this one, you get 1K. And then you have a couple more of the LTC and then another of the ADS. And then if you keep scrolling down, we do get to the ADS 122C04. And this one it's much more expensive. It's like $2 more than the LTC. This one does 4 inputs, also 2 differential. But it gives you 2,000 samples per second. So the question is, are we willing to put up with 1 input and 7.5 samples per second? Probably. It's not bad. And for temperature measurements, you don't have to go very fast. However, I was looking at this and I was like, well, I think people would want to use it for maybe other measurements. If I was going to make up a breakout board, it might not be just for temperature. It might be for, maybe people would use it for stuff like strain gauges or other Wheatstone bridges where they want faster results. So in the end, I actually sort of decided to check out the ADS 1219 because I think the 1,000 samples per second also means you can do oversampling and then averaging, which might be kind of nice. Whereas I feel like 7.5 is sluggish, but 1K, you can do that over I2C pretty happily. So this is my pick for a 24-bit I2C ADC. Not the cheapest one, but I think is going to give you a really good result, and lots of it in stock at DigiKey. So check this out. The other one's also probably very good if you don't need 1,000 samples per second.
All right. That's right, Church.
Where in the world is that part I need? The Great Search with DigiKey.
That's our show.
Okay, that's our show.
All right. I will see everybody later, and I'll try not to get in too much trouble. This is why I don't have a show, by the way. This is why it's Desk of Ladyada.
Yeah.
Because
We're special guest.
ain't no Desk of Phil.
Yeah, we could.
We're not going to do it, though.
No, we have citizens.
Nope. Yeah, we'll do that.
But then we're both citizens.
Yeah, it still could be your fault, not my
Okay.
fault. I just
Wait,
work
what?
here. I just do what I'm told.
What?
You don't understand, everybody. This is all her idea.
That's not.
Okay, I got to go.
Bye, everybody.